Hello everybody, welcome to this video. In this video, we will learn about a new topic called differentiation. Okay, this is chapter 14 of your textbook. Okay, so what is differentiation? Okay, differentiation is actually just a gradient function. Okay, so if you differentiate a function, you will get its gradient function, which is another function. Okay, what do we have to know after today? We will have to know that the derivative, or after you differentiate a function, it is called the derivative of a function, okay, of a function fx, is actually the gradient of the tangent, okay, to the graph y equals to fx at a certain point, let's say x equals to a. Okay, so let me illustrate this. So let's say if I have a function fx, so let's say if I do a let's say I do differentiation and I get f prime of x. Okay, so let's say this point is x equals to a. Okay, so the gradient which we will obtain this way would be the same as the gradient that we get from this function. Okay, so this value here, f prime of a, this value here would actually be this gradient that we have here. Okay, so this is what it's saying. Okay, don't worry if you do not understand, I'll further elaborate on this. Okay, the derivative as a rate of change, understanding derivative as a rate of change, and using our standard notation such as f prime of x, f double prime of x, dy dx, d2y dx squared. Okay, so f prime of x is actually equivalent to saying dy dx, or we could also say that it is y prime. If y is equals to fx, then y prime is equals to f prime of x. Okay, similarly, if we do double differentiation, this is equivalent to d2y dx square, and also equivalent to y double prime. Okay, so as promised, I would further elaborate on what this differentiation thing is. Okay, so we have learned in Emaths that I have a graph yx, y is equals to mx plus c, this is c, and then the gradient is just x2 minus y2 minus y1 over x2 minus x1, which is equals to my m. Okay, so for example, if I take the gradient of this point, the gradient of this point, all the different gradients for the different x values, okay, and then I plot it, 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 and then I call this gradient. Okay, call this a gradient function, sort of saying. Okay, and this other coordinate is this other axis is x. So if I find all the different gradients, it will all just give me m, because the gradient of a straight line at any point of x would just be m. Okay, so what I have is a straight line. It's supposed to pass through all these points, but it's a poor drawing. So I would be able to plot a so-called gradient function. Okay, but this is empiric. I just got it by plotting. Okay, so the question is, can we find such a function? Okay, so answer is yes, we could find it. We can find such a function, not by empiric, but we can there's actually a standard set of procedures to find this gradient function. Okay, now so after if we can find it, then we want to ask ourselves, is it possible that, let's say I have a curve. Okay, so we are not only limited to lines, can we also find such a gradient function. Okay, so the curve should look like this. Okay, so this is also a so-called a gradient function. Okay, so answer is turns out that we can. So for example, over here, x equals to a. Okay, by right, if I would want to find the gradient, I would have to find a tangent line. Okay, and then use the formula. The formula, I guess you are very familiar with it. Just y2 minus y1 over x2 minus x1. This will give me the gradient. Okay, so I do it not only for a but all the different points of x, and then I plot out a gradient function. Okay, I should get a graph like this. But the question is, can we find such a function? And the answer is yes. So if I know the function y is equals to fx over here, by finding f prime of x, okay, I would actually get the gradient function. Okay, so actually this is equivalent. Okay, so as I have mentioned, f prime of x is just a function that describes the gradient of a function y equals to fx. Okay, it can be denoted as f prime of x or dy dx or y prime. Okay, similarly, the gradient of f prime of x is also denoted as f double prime of x, d2y dx square, or y double prime. Okay, another point to take note is that the rate of change is not only restricted to y and x. It can be dy dt, which is, let's say y is a function of time. Okay, and then we can take the derivative with respect to time. Okay, so things like if y is the displacement, then its derivative with respect to time would be its velocity. Okay, so certain applications to physics. Okay, so let's summarize what we have learned. Okay, this is essentially what we have seen in the previous slide. Okay, and we have also learned something else, which is that differentiation is actually the gradient of a function. By finding the gradient of a function, finding the gradient function, as I have illustrated. Okay, with that, I thank you very much. I hope you are excited to know how to find this gradient function. I am very excited about it. I will see you in the next video. Okay, thank you.